Hi, I'm Aarti, and today I will be presenting advanced document retrieval with cross-encoder reranking and hybrid search, which is a continuation of my information retrieval series. For this part of the project, I have enhanced basic semantic search system with two major improvements. First is cross-encoder reranking, which implements two-stage retrieval pipeline that combines the speed of bi-encoder search with the accuracy of cross-encoder scoring. Second, I have used hybrid search, which uses BM25 and reciprocal rank fusion. This combines the keyword matching with semantic search to handle queries that benefit from the exact keyword matches. This is the same architecture that is being used by Google, Bing, and Elasticsearch for production search systems. And by combining these three techniques, we get both speed and accuracy. So now let's have a look at our project file explorer. We have two additional files. One is the reranker file and the hybrid file here. But before I demonstrate my code, I would start my Pytest running over here because the code coverage or the testing, it takes time. So I will be starting my UV run Pytest. And why my code coverage thing continues, I can start explaining what I have done. In my reranker file, this is the file where I have implemented my cross-encoder model. I have also implemented the sentence transformer for the same. And here I have a class called cross-encoder reranker, and it implements the reranking logic over here, including the top K. And I have a hybrid file, the same file, which implements the BM25 and RRF parameter, here. So it also contains the logic related to this. Class is called the hybrid searcher, which has been working that. Now let's have a look at the demo. For this, I've already started the server at localhost 8000, and the server is already started over here. Let's have a look at our web interface. Okay, this is our website. Let me type a query, which is like, what happens when Dracula visits Lucy at night? I'll be hitting enter. So we have a result over here. So notice how the results have been grouped based on the relevance type over here. So what actually is happening behind the scene is that the system is first trying to retrieve 20 candidates using the bi-encoder semantic search, then re-ranking those 20 using the cross-encoder, and finally returning the 5 most relevant result. So we have already set 5 over here, which is the default. The top case to be 5 here. And the results are actually grouped based by relevance based on the re-rank scores. So the system would show the closely matched, moderately relevant, and sometimes loosely relevant as well, if there are any. So you can see the top result is showing the chunk number 115 over here with a re-rank score is somewhere around like 0.71. And here there would be terms related to Lucy, and there is a Dracula over here. And similarly, all those chunks, the next relevant chunk is like 150, and it too consists of all these words over here, and all top 5 it will show. So moderately relevant is also shown over here. So let us try with another query, which is garlic crucifix vampire protection. Okay, hitting enter again. So with the hybrid search enabled, this query benefits from both semantic understanding and keyword matching. The chunks containing specific term like garlic and crucifix would rank higher, which we're going to see it right now. It's only because the BM25 captures the exact keyword matches, and semantic searches understands the context of it, and then RRF boosted the documents appearing in both of these lists. Okay, so we have the result over here. We have this moderately relevant, in which the chunk number 257 consists of these terms. We can find garlic, crucifix, and vampire as well in here. So here we have this garlic mentioned here. Crucifix is also mentioned here. And similar to that, we have other chunks as well. For top K, we have like option 3, 5, 10, 15, and 20 present here. Let's get back to our code base again. Now, you might want to ask like why re-ranking is so important. It is because the bi-encoders, which we have used in our lab 4, encodes queries and documents independently. Then we compare them using cosine similarities. This is fast as we compute all the document embeddings and just embed the query at the search time. However, it is limited because the model never gets to see how these query and the documents are related to each other. Cross-encoders, on the other hand, encode these query and documents together as a single input. This allows the model to understand their interactions and make more accurate and relevant judgments. But this is quite slower because we must process each and every document pair. So what's the solution for this? The solution is implementing a two-stage pipeline. In the first stage, we use the bi-encoder to quickly retrieve the 20 candidate documents. And in the second stage, we will be using the cross-encoder to re-rank these 20 candidates and then return the top 5 of them. This is the exact approach which is being used by major search engines. Now let's talk about the hybrid search, which I've also implemented. The challenge with the semantic search alone is that it might miss some documents with exact keyword matches. BM25, which is a traditional information retrieval algorithm, it captures keyword frequencies but ignores the semantic meaning. Hence, hybrid search combines both approaches using the reciprocal rank fusion, or RRF. Here's how it works. We run the semantic search engine and BM25 keyword search in parallel. Each produces ranked list, and then RRF combines these ranked lists using the formula is 1 by divided by k plus the rank, and the k value is usually 60. The key insight is that the document appearing in both of these lists list ranks gets a high combined scores. So if a document which ranks highly semantically and contains the exact keywords, it gets boosted on top. This makes the system robust across like different queries types, whether they're conceptual or searches or keyword specific queries. All right, so we have our test coverage results ready. You can see the total coverage that we have got is 92%, and total test cases that we had for this project, it was 96, and all of them have passed. It took us around like 21 minutes. Actually, it's quite a long time it took, but we finally did it. So now let me verify the code quality. For this, we can run UV run rough check. It says all checks have been passed. We can also run UV run format. 22 files left unchanged. So it means like no linting issues have been found. So that is it for today. Thank you for watching.